Hello, everyone. My name is Bhairav. So I'm the host of the Band and Mike show. So today we have with us Mr. Jason Lowe from Oracle. So welcome to the show, Mr. Lowe. It's a pleasure to have you with us.
Thanks for the opportunity to actually come onto your podcast.
Can you tell us a bit about yourself, your background? Let's start with that.
As you just said, my I work for Oracle, and my role at Oracle is a cloud engineer. So in that context, is I'm working with our customers and our potential customers around Oracle Cloud Infrastructure. So, and specifically in that role, what we do is actually look at customer problems, what are their pain points, and what are they trying to achieve, and then how do we actually help and partner with them to deliver on those kind of outcomes that they're trying to get to. So I'm based here in Australia, so predominantly my role is within the Japan Asia Pacific role. However, most of the things that we do is globally. So even though I'm based here in Queensland, Brisbane, the interconnection into what we do across the US, Canada, into Latin America, into Europe as well, it's a well-connected ecosystem that I belong to.
Thank you so much for sharing that introduction. And it's great to have you here. So, like recently the boom is around AI. So let's get into that a bit. So yeah, so what's your perspective on, like there are a lot of students who want to get into this field. There are a lot of other aspects in tech, but people want to learn more about AI and maybe go into this field. So what's your advice to those students who are just starting out?
That's a great question. And I think if you look at even last 3, 4 years where the AI boom, as you say, has grown significantly, and even from an Oracle standpoint, the massive growth in terms of investments, in terms of infrastructure, and the partnerships with the likes of that are building out these large language models. And it's not just about large language models, it's all types of AI. There's massive growth and massive industry that's booming, as you say. Now, in terms of getting into the space of AI, I'd probably look at it a little bit differently in terms of AI being almost that pinnacle of, let's say, new capability or emerging capability to get into. And as you know yourself, AI as a industry is surrounded by many other aspects that we need to get together and do it right to bring AI to the fore to really be successful in doing that. So as a student, and I say student, we're not necessarily just talking, just even though I work for Oracle and I come from a computer science background and electronics engineering background, I'm not just talking about the tech, but how does AI influence someone that's doing a business degree? How does AI impact someone that is in the healthcare industry, right? Or if I'm deep into tech, but I've got a more of a software development aspect in terms of what I'm doing with comp science, or I'm doing things with information systems, right? So even if you a student across many of those, then there's an AI element to any of those that I can see being part of that path. The last thing that I'll say on this bit here is AI is just a tool to accelerate our understanding around vast amounts of data in terms of how we want to use that. So whether it be from creating insights in terms of creating something that we don't better understanding about something that we don't know before, or changing the experience around what we're trying to achieve, whether it be optimizing our process or creating new content. So more that generative AI aspect, right? So are we changing the way that we're doing things? So there's probably a couple of different ways that we can look at AI and getting into AI as a student.
I really want to know because there are a lot of skills which a student needs to learn before getting into this field, right? So, like, what specific areas do you think they should focus on while before they get into this field or start a degree in this area? Because there are, there might be a different, like, there are large language models, there are like, there are like detection models, and there are so many areas in this field, right? So
Mm.
it can get a bit like overwhelming when you are just entering this world. What's your advice to them? Just to them before they start their careers in this field?
I think it really comes down into where is your passion and start from there. Um, if we think it more generically in terms of the life cycle of software, um, then if you're actually more in the university and academic space and doing research, there's so much you can do in AI in that research space. So if you think about responsible AI, AI frameworks, or different techniques that universities are coming up with, new algorithms, and how do you apply that in context, there's a lot of work that can be done in an academic and research aspect. So that's probably one thing. And then when you translate that research into a product, then there's really about the organizations that are building up models or building up these API, software as a service offerings around AI. So, are you going to be more about wanting to get into the building of AI and AI infrastructure? So, as an example, is part if you're in a hardware and that's where you're focused, then potentially building out AI infrastructure offerings, potentially on mobile phones or on edge devices or in where a lot of the investments are is actually in cloud. Are is that where your passion is? Is that where your passion? And then thirdly is the other aspect, which is probably where I sit most and do most of my work, is I'm not necessarily building out these offerings. I'm not necessarily researching on that, but I'm actually on the consumption side of these AI services where taking your skills around business analysis, design thinking, and also then doing solution architectures and developing solutions using these frameworks, then delivering on specific outcomes for customers, right? So, which is going to be more around your business analyst, being more around your software development, but actually in a more of an industry context. So if you're in finance or healthcare or engineering or even in a marketing or sales sense, then how does AI fit into that and building solutions or building business processes that align to that? Right. So there's probably different angles in terms of where you want to start, but ultimately, um, getting your foundations around each one of these is probably the first part of the step of getting into AI.
Amazing. And you mentioned about like edge computing, and building AI infrastructure. So I just wanted to go a bit into that, like so that the audience gets, a bigger picture. So like, how do you think that can you explain about edge computing and how does it differ from traditional cloud computing?
Um, Fantastic. So edge computing, if we think about it, then um, computing power in many different shapes and forms exists, whether it be I'm pointing to my phone, um, laptops, or even smart devices that sit out in the wild with the Internet of Things. So nowadays, a lot of things in terms of lights, smart meters, um, in agriculture, and what devices that sit out there in paddocks to help monitor and manage the environment. There's all these devices that actually sit out there. Raspberry Pis, as an example, sitting out there controlling window frames and just shielding blinds to do things in the home. So all these devices are, in a broad sense, edge devices. They're not necessarily your traditional computer that sits in a data center or even on your laptop where it where there is a traditional compute involved. So that's really those edge devices. Edge devices also then bring in uh, like the cameras that we have, the beacons that we have. So RFID devices where you walk through different spaces. These are also what I classify in that space as edge devices. So they're capturing data. Now, when we think about the other spectrum would be the cloud infrastructure or even infrastructure that sits in a organization's data center. It's full of compute and servers where AI and GPU and more modern versions of AI infrastructure, all that typically sits. Now, the two spectrums of where we're talking about that, there's economies of scale. All right. So yes, in data centers, there's a lot of compute. It's all in the one spot. However, it's, as I said, it's all in one spot. So if your data and what you're working on is just there, then by all means, that makes sense. So there's a center of gravity in terms of where the data lives. And then on the top of that, where AI that can interact with that data can also exist. Now, this is where it gets interesting when you start looking at AI on edge devices. What if you were able to run AI models directly on the camera or on a phone or directly in the field in a paddock? What would that mean? Would you need to send the data out to the cloud or to a data center and bring that back? All right. So you start getting into more real-time autonomous style of AI decisions, not necessarily to the same extent that you could run in a cloud infrastructure, but potentially when you've got the scale of instead of bringing everything back to one there, you might have thousands of cameras. What could it mean to scale that infrastructure and scale those AIs distributed across those cameras and provide those decision points on the edge?
And I have also seen like a lot of hackathons which are being focused on, edge computing, maybe in the space of IoT. So how do you see like the role of cloud evolving as, edge computing becomes more and more prevalent?
Edge computing, as it gets more prevalent, I think from a hackathon and a learning experience, there is a case of a digital divide. Unless you got access to those devices, and we're typically talking about hardware devices. So unless you got access to that, then how do you get into that space? Do you need as a student, do you need to go buy these devices to get involved? Um, and I'd even go back to the days when mobile devices and developing on mobile devices was I suppose more difficult than what it is today. We were building out these mobile emulators on on laptops, on cloud, on servers to replicate the many different variations of devices that potentially out there. So, because back then there was not just iOS or Android, there were hundreds of different phones and different phone types that you needed to do. Right. So I find that in the space of edge devices and nowadays, cloud to actually help that learning process in a cloud sense, such that you've got the accessibility, you can test these things, you can create digital twins of these edge devices. It allows you to experiment at a lot cheaper cost without and learn from those experiences without actually investing in a room full of technology.
If you would, if you are like, I would take a recommendation on this, like, where while there are a lot of students who are coming into computer science, they want to pursue a CS degree, but like you see like the need for software engineers, like entry level software engineers, is in danger. Many people are saying because of LLMs, there are a lot of AI tools like Replit or maybe other tools which are causing this danger. So right, so many students are scared about what programming languages they should learn. So what are your top three programming languages you think are most relevant now?
Yeah, that's an interesting one because um, was it recently, even just recently, Java had a significant birthday. I think it's actually was around about the foot well 40 year mark in terms of Java, right? And Java's still quite strong in terms of a coding language. Um, so and I've actually started seeing C++ coming back in different shapes and forms, especially around these edge devices. Um, so my advice actually is I don't think there is the one language. There's going to be ones that are common, right? So TypeScript, Java, Python, Node, and even TypeScript into Node.js into that kind of space. Um, they're probably the four prevalent ones. Scala, Go, Rust, even PHP to some extent in some different areas are great. Are from a very much a case of that more that data science background still prevalent in research, right? So I don't think there is the one or two that actually fits that. I also, if you come back into the different spaces where you look at academic and research, the internal engineering of AI infrastructure and services versus the consumption of the AI, there's different programming languages that would fit for each of those. All right, so I'm seeing more Python and R in the research space. I actually probably see more Java and some of the things like Go being in that middle space, and a few of these other more foundational languages if you're building up these services. And then I see a raft of many different types of languages in terms of consumption and creating APIs. And I think the interesting one when we start looking at the meeting the customer and using AI and using software development skills, we actually probably open up even more so when we start looking at low code platforms or or even other platforms such as doing SQL and writing SQL packages that plug that call APIs out. Right. So there's other languages that fit in that space that aren't your traditional software development. So I think software development as a concept around coding constructs, how you code, how you use debug, how you actually define modular solutions. Great that you've got a coding language, but those practices that I just mentioned are probably more important such that you can then transfer between different languages if you need to.
And I also want to go, shift our focus to, uh, hackathons, and you are a mentor and a judge. You have organized many hackathons, and so like before getting into hackathons, I also want to learn, like, first of all, give the audience a brief idea about what are hackathons and what are the different types of hackathons which they should go for, and what are the skills you require before you participate in a hackathon.
Yeah, so hackathon can come in many different shapes and forms. And over the years, there's probably been let- there's let's say hackathon as a term is really it can really shape depending on the organization and those kind of outcomes. But ultimately, the simple thing is there is a problem statement associated to the hackathon, and then over a period of time, and time itself becomes part of that critical nature around hackathons. Then there's a process of being creative around that to solving that problem. And then from there, depending on the hackathon, there's an output required. So there's a judging criteria related to those hackathons, And then from there, there's um, a judging criteria, presentation criteria to actually come up with sometimes winners, but sometimes it is in the more social and more community centric ones. It's just about sharing experiences and sharing ideas. So over the course of the probably coming up to the last 10 years being involved in hackathons, then tip, especially when we're looking at AI ones typically, if you go back about 5 years with platforms like Kaggle and the like, they're very much a case of problem, data set, trying to solve that with an algorithm. So it's very technical driven with a quality aspect to that. So the ranking goes into more about what's your error rate and what's your performance around delivering to that goal. So that's one type of hackathon that typically they're seeing. Another one is a bit more creative where we're looking at a business problem where, and if we think about startups and scale ups and those entrepreneurship style, innovation style hackathons, then typically it's a business problem. So it may be an industry problem or it may be a specific business problem that they're trying to solve. But then there may be a technical element to it. Oh, use AI, use a data science, use a low code platform, use blockchain in that kind of frame. And then ultimately through that, there may be two steps. There's two types. One, go from the problem using a design thinking model where you go from discover, define, design, develop. Then you may only do that first bit. So you may get to, okay, what is the problem? And you go deep in the research aspect of solving that problem to then get to just a problem definition or a defined business model that you may go out to market. And then some hackathons go even to the next step of, okay, now that I know what needs to be solved, how do I solve it? Oh, do I use IoT? Do I use AI? Do I use a low code platform? How do I present that? Um, even even creating these prototypes and taking out to market and getting market feedback in terms of what works. All right. So some of those there. And then once you've got that developed, then typically is either going to be a pitch of some sort, a pitch of the business model, a pitch of the go to market in terms of how much revenue that you're going to generate, a pitch of the solution and the technology that you've actually built as part of that. Now, depending on the format, then some of those are live and pitched to a panel. Some of the ones that I did over COVID, where we had over 4,000 participants in the one space, people created 3 to 5 minute video pictures with a code repository, with a presentation, and then you go through a massive exercise of drilling that down to uh, maybe one or two winners out of those 4,000 participants, which is it does take time. So um, and some of those, well, and the last thing that I'll say on that format, um, some of them are open in terms of, hey, um, open to students. Some of them have prize money associated to it. But then on the flip side, some of these are actually done internally within organizations. So um, recently, a local organization did one internally for their staff so they can do that as part of their product development. Oh, we've got a customer problem. We bring the whole business together and we do that. So there's plenty of different formats that hackathons, especially over the last 10 years that I've seen, many different shapes and forms that it comes in.
That's amazing. And I was going through some research before, our podcast. So I found out that, like, the word hackathon comes it's derived from marathon. So like it's hacking plus marathon. So they came up with hackathons. So I feel like the points you mentioned are so relevant. I feel like the hackathons can be applied to like a wide array of problems, right? Like in different industries. So I wanted to share a personal experience of mine. So last year, like we see that there are a lot of agriculture problems in India related to climate change and other aspects regarding crops. My father, he works in an organization called Tea Research Association, where they do research about tea and there are different research techniques which are involved in that. So last year we came up with an idea where we did the first hackathon in tea. So we sent out invitations to all the students around India in different colleges. They came, they participated, and we gave them a sort of generic problem statements, around 5 to 6 problem statements from where they can choose. And they chose some of the problem statements which were drafted by the scientists who are working in the organization about tea and how climate change is affecting the tea production and other problems which are faced by the industry. And the students came up with like very innovative solutions through those hackathons. I feel like the hackathons can be a medium to connect the younger generation to the experts who are working in this field and bridge that gap so that there's more room for collaboration in these problems like in major problems which are threatening the world. I feel hackathons can be that medium, and it also gives you a platform about how students can contribute to society as well.
I totally agree. And there's a collaboration that I currently have here where I am with a university where we are taking that similar approach here where and the collaboration is actually with the School of Business. So business students with an information systems background. So their main goal is actually to create business models and innovative business models. However, the collaboration with us have been around digital solutions to solve a worthy and sustainable goal in terms of whether it be climate change, whether it be housing crisis, whether it be something more on a global scale. So the collaboration and the mentoring, as you say, is a fantastic way of connecting, not just people within the team. So typically, these things are the ones that I find more valuable are the ones that are team based as opposed to individual hackathons because you get that diversity of thinking across that and bring very different people together. But then similarly, when you bring in problem owners, stakeholders, mentors, and also collaborators in terms of technology and business, then there's much to gain in terms of that employability pathway, so to speak, connecting students and learners with practitioners, uh, because there's many different ways that people can contribute.
Amazing. And I wanted to know from you that what are the major resources which you found helpful in learning more about like machine learning, deep learning, the different aspects of AI?
Um, I think that in itself, in terms of resources, there's many lists of different places you can go. Um, even at this point in time, using using different large language models to actually go help find them is actually quite useful. Um, but from a technologist, there's typically lots of resources, even on GitHub, as an example of many different things. Um, I think even just doing basic searches, um, keyword searches, I know it's not necessarily high tech, but keyword searches, I think when you're starting, then then being curious about something that you're passionate about, and then bringing a lens of what does AI fit into that. All right. So to me, like with anything, with whether you talk about searching or large language models or prompt engineering, it is all about your context and how you want to frame that. Even bringing that down to the quality of a prompt, the quality of a prompt of how you think about that, how you contextualize that, how you want to create a better prompt in terms of the shots that you put into that, right? All those kind of things enrich what you find, right? So I know that that's a bit of a double entendre in terms of, hey, how do I find these? Um, Being curious about what's your question and why you want to find that out will create context, and that will give you and that will guide you in terms of what areas of focus, right? So if you as you find things around research and AI research, then you'll those things will direct you into more journals and what people are doing in that space, let alone if you're thinking about, okay, how do I actually do more ML ops? So doing more operationalizing and productionizing AI, so AI ops, even now security and security around data, that in itself, I don't think there's ever going to be one place because it's there's so much that's happening in the space. B, there's so much new that's happening in the space. Do you want to pick up something that is 2 years old, or do you want to pick up something that is just released yesterday by someone that you haven't searched for, right? So I think that search and that discovery of that list, it will be ever evolving. But because, as you said right at the beginning, it's booming and lots of different people are coming from very, very much different perspectives.
Like I've seen like most of the researchers working in LLMs or AI are not from like a pure software engineering background. Like they are
No.
most physicists, like mathematicians. And like coming to this to hackathons, and
Mm.
wanted to know, like, how can participating in more and more hackathons, how can it increase your, how can it accelerate the AI learning curve? How do you think that impacts the way you are learning about AI and machine learning? How do hackathons play a major role in this?
So the one thing that we touched on through both your personal experience and what I mentioned before, it is that combination and that amalgamation, augmentation of business and IT, and bring that in the one space so you can get to that outcome as quick as you can. Um, so the the aspect around that is, and where AI fits in, then it's really about finding those opportunities of those hackathons where you can express AI in that context. So if we think about there's there's places, and even just similar to this, searching up the word hackathon, there's hundreds of thousands of different hackathons across the world. Some are virtual, some are in person, uh, some are part of universities, some are more public, more enterprise based. I say enterprise, but more corporate. So finding those opportunities, I don't think you actually need to find just AI hackathons. I think you could just find any hackathon, and then with you and with your experience and what you want to bring to the table, bring that AI learning to the fore. So if you're thinking about, hey, I'm a software developer and I'm starting to get into more the MCP, building out MCP models and servers to actually build that, and then you've already got your frameworks of different things, and you got your large language model that you've got access to as part of that. Why don't you bring that as a resource to a team that doesn't have AI in there, and you can build out your capability and build your learning of AI to solve a problem that has not been described, right? So there's other ways. I don't think you just need to narrow in. You can, like I was saying before, in that design thing, diverge your your field of vision in terms of where you could apply AI, and then bring AI into that context. So um, pretty much go into any aspect, even ones that are just focused on the design, right? So with design thinking or design jams, which is bringing up to a business model, you can still bring AI to the fold, but make it very data driven. So a lot of those have surveys, a lot of those need to go out to research different aspects of that. Why don't you bring AI or large language models or generative AI to be more creative around problems? Why don't you use AI in that context to create problem statements or create surveys that you could actually ask, or the way that you want to articulate emails or ways that we want to present websites to people, and use that as a tool within that design context. All right. So there's many different ways and shapes and forms that AI tools or software developer or even low code tools where AI can exist if you're coming from a business angle, right? So I think the context of where can we run it really comes into the how creative you want to be.
That's a very interesting point you mentioned, because like there are so many students who come up to me, and they say that we are scared of participating in hackathons because they think they're not well versed in coding. They don't know as many languages, or maybe they are unaware of the architectures which may be used in the hackathon. So like what are the skills which you think, what are the non-technical skills which you think are important while participating in hackathons, and like learning about maybe these AI tools? So what are some of the non-technical skills which are worth learning?
I think in a hackathon, especially when we're looking at ones that are more that startup business focused, similar to the one that you talked about before, those ones there, collaboration and being empathetic with your broader team, because typically hackathons, people come into that either if they're highly skilled and motivated and just want to win, then that's one type. But then there's a broader team, broader cohort in hackathons that they're just to learn, right? So if you got a team that is purely there to learn, and hey, everyone wants to win, but the primary focus is to learn, then being empathetic in terms of and being vulnerable and transparent in terms of what are you there to learn, right? Now, if everyone gives their 110% to learn and deliver on that, then I don't think anyone can be too disgruntled if things aren't actually perfect because people are there to learn. Now, I think so that teaming, especially getting out there, being vulnerable, being able to collaborate and actually bring people in to form that team, I think that's pretty much the one of the key things. The other part to that is is being prepared. So if you are looking at to come into a hackathon with a specific goal, what are you there to learn? What do you want to build upon? So even if you're starting from almost nothing, go learn and explore. Okay, if I've got Python in my background, then maybe what AI frameworks with Python are out there that I can build myself. And maybe starting off with some LangChain, LangGraph, or understanding some of these other frameworks that you can then start building upon, to even just building something simple, right? Maybe part of that is learning, okay, how do I host a model myself using Olama as an example and downloading them. So with Olama, you can you can install it yourself, or maybe a prereq is learning how more things around containerization, Podman, Docker, using containerization techniques to actually stand up the infrastructure and building these things. So using something like Streamlit or using something like some other framework to present that chat style interface within that. If you can prepare yourself and bring something that makes someone else's life so much easier because that's not their expertise, then you're already winning. Right? You've got capability that you're bringing to the table that no one else within that team already has. So then what you're learning on top of that is actually just a bonus. So that's probably the two things that I've got in hand.
That's great. Even like the point you mentioned is so relevant because even in my case, I have seen that when I have gone into hackathons, I felt a fear that I might not do well in the hackathon. Or I might not win the hackathon. But the thing is that when I participated, I found that I learned so much more while participating, learning about new infrastructures, how to go about things. I feel like while you are learning a course in a university, uh, you get to learn about the concepts and the different types of theory. But I feel if you participate more and more in hackathons, I feel you can apply those concepts and learn even more. I feel like learn the maybe the technical the minute details and like the other things in that area. So I feel like it's a very important point you mentioned, and I wanted to know like because many students are unsure about whether they should pursue a CS degree or a computer science degree now because there has been so much boom in the LLM space. So what areas do you think students should focus on right now? Should they go for a CS degree or should they go for a completely different degree which aligns with the current AI boom, or should they learn more into should they lean their degree more into something like quantum computing, hardware, maybe electrical engineering, you know. What's your thought on that? And, what's your take on that?
I wish I had a crystal ball in terms of where the future goes, especially with um, and quantum computing um, in that space. But uh, I think even for myself, there is a continual learning process and evolving process. So if I think about when I first came out of university, um, it was one that was a very different world. It was right in the beginnings of the internet and there was everything emerging. So Java was just came out. We were doing that at university. But ultimately, where you go, things like computer science, if you focus more on not necessarily the language or the framework, because frameworks and languages, they may come and go. So we think about, especially in the space of containers and um, Python, and even with TypeScript and Node.js and NPM, there's so many different frameworks and APIs that you can call that it's a always evolving space. All right. So sure, understand that we need to look at learning a craft at that point in time. So computer science is going to teach you techniques with a specific language, different ways of thinking, the way that you actually build those things out. But when I was talking before about those transferable skills, you got to elevate yourself up such that, hey, if I'm just talking about modularization when building out an application, that modularization thinking and building interfaces between things, that's no different from what I learned in the late 90s, early 2000s around uh, banking systems or talking to mainframes or remote communication between multiple layers of software, between something that's built on the desktop with something that was built in the middle space to do all the business logic and built on, and then you got a database in the back end. All those aspects in terms of the modules and APIs, that still exists. All right. How we communicate, what do we build, and what do we define those APIs? If we bring that into the AI world, that is the exact same problem in thinking around NCP servers. All right. So what is the interface? What are we trying to do? How do we contextualize the AI model behind that? Do we build with agentic AI and building our agents? Do we make them very specific, or do we have something that's general? How does that agent fit into broader ecosystems of business processes and data? Is it something that is plugged into data warehouses where it's more for insights? That kind of style of thinking is no different from systems that were built 20, 30 years ago, right? So is comp science, is those things still relevant? Yes. Is the coding language or is the framework of the day still relevant in 20, 30 years' time? Maybe, maybe not. Right? But as you evolve, we need to elevate that thinking to something that is transferable in terms of how do we look at the way that we build code or build AI agents, or actually even look at user experiences. Right? So there's a raft of ways that we can look at. So I don't think there's ever going to be the right or wrong. We just need to evolve our thinking in terms of how do we apply what we've learnt into different contexts.
So much, Mr. Lowe, for your insights. I think it has been really valuable to our audience. And I think we had a really productive session today. And I would like to thank you for taking out the time for such an amazing session. As personally, I got to learn a lot from you from this interaction. And thank you so much for this episode.
Thanks very much, Bhairav.
Thank you.